So this is a deBroglie wavelength, and then when you first time you see it, also the answer key is provided in the your crib sheet. And so, okay, deBroglie wavelength. So lambda. Lambda is Planck constant divided by p. You know what p is? It's a momentum. Okay, so you don't need to learn the new symbol. Momentum is just mass times velocity. So this is something that I just have to figure it out. So the question was to calculate those, and then so all I need to figure out is Planck constant. I can read it, and it's actually provided at the bottom here. And then the mass electron is provided in kilograms. That's even nice. And I don't know the velocity here. Okay, so I need to calculate the velocity from the information shown up, and there is a information shown up here. Okay, so this one is, so you shine the electrons, and then the electrons are coming out, and they show you that the kinetic energy. So this one, right? The statement here, this one is essentially kinetic energy. That's the part that I know. And the kinetic energy is, you guys remember your physics 101? Half mv squared. That's the definition of kinetic energy. And so I can relate that, okay, if kinetic energy is given, I can calculate my v and plug it in, that number's there, and that's how I can do. And there's another way is, actually I want to calculate the whole thing, which is mv, using the kinetic energy. That's the second option that you can take. The most tricky part is actually here. You see the electron volt? That's an energy unit. Electron volt is an energy unit mainly used by electrical engineers and electronical engineers in semiconductor business. And as you show here, electron volts, joule can be changed. And this is a conversion factor that I have to use for mine. Okay. So having said that, what am I going to do is I want to first, okay, kinetic energy. That is half times me v squared. That's for the electrons. And then I am going to rearrange it. 2 times kinetic energy is me v squared. Okay? So where I'm getting at here is I am going to multiply this one on both sides by mass of electrons. And then I'm trying to essentially make a shortcut of calculating this term from the beginning. Okay? So what I have done now is simply saying this term here becomes me velocity squared is simply 2 times mass of electron times kinetic energy. So therefore, MeV, which is a momentum, is a square root of 2 times me. Okay. So far so good, but there's a little problem that I have to deal with, which is converting kinetic energy from the electron volts to the joule. So here, so 2, and what was the mass? Well, shown up here, right? So I'll just use the first 2 numbers, 9.1, 10 to the minus 31 kilogram. Okay, that's the one. And the energy is, what was the energy? 506. Okay. 506 electron volts. And all you need to do is remember the unit conversion. 1 electron volts, what's the number there? 1.6 to the 10 to the minus 19. So when I finish that, I have converted everything into this units. by doing so, this annoying electron volt is gone. So all this term here is a kilogram and the joule showing up here. Okay. And so, do you guys remember what joule actually can be broken into the units? Joule is Newton times meter. Oh, remember that, right? You know, Newton is a force. Force is a F equal ma. Mass times acceleration, which is a length divided by time square. You remember all this? So refresh your memory that doing this. So this one is essentially mass times length, and you multiply meter over time. So this is when it comes down to, this comes in handy for you to remember this. And actually, it's not a bad exercise for you to say what this unit really coming down to. This is a joule, which is like this. There's a kilogram. Multiply joule times kilogram. You will have joule times kilogram as a kilogram square, meter per second square, which is the same as a meter. The momentum, the whole thing is a square value, and you take the square root on the numbers. So that should work out for you. Okay? So, and then the other thing that you want to be careful is, I want to highlight here, you look at these numbers here. This is something that you just do not rely on the calculator. I want to kind of have a separation of numbers. So I'm just going to deal with the numbers that is not in the power, to the 10 to the power, and just I'm going to write these other numbers down. And that makes it actually easier to calculate this. So if you do that, that's a 14734. And then the other part, which is shown as this, that will 10 to the minus 50. Okay? And that's, so then I can finally get to my number that I'm looking for, which is a 121 times 10 to the minus 25. Right? So that the square root conversion is easy, because the 10 to the 50 just a half, so that becomes 25. And what's the unit on this? Kilogram meter per second. That is a momentum, right? So you got this momentum unit. I got this part. And then, since I got my momentum part, this is I'm in business, right? So I'm in a business here. So which is number 2, which is a Broglie wavelength, which is MEV over H. All I need to write down is 6.6 really 10 to the minus 34, 121. And then this is a kilogram meter per second. The one at the top is joule times second. So that's a unit. And if you remember the joule unit that I told you before, this is also nice kind of refresh your memory. Joule was a kilogram. Meter square, second square, times second, right? By doing so, what's have left? You have left out, kilograms are gone, meters are gone in this way, and this is essentially left with per second, and per second is gone. Only surviving term is a meter here. So make sure that you kind of double check your answers. And also, like I said, I want to separate my calculation on here on both sides this way. So all I need to do is get this number calculated, and this number is 0.055 multiplied by 10 to the minus 34 plus 25. Okay. So that's an easier way to handle this. You know, unknowingly small number, 10 to the minus 34. You have no time to punch all the thing, or you can write this different form of expression. But I think that this is also give you a pretty short way, and that will be a 0.055 10 to the minus 9, and answer is meter. Okay, so that's the answer. And somebody would like to write it, oh, that's the same as 0.55 nanometer, right? Because of this 10 to the minus 9, this nanometer. Some other one will say 55 picometer. Have you heard about picometer? Pico means 10 to the minus 12. Okay? So that's the one. The usual molecule is about 500 picometer. Okay? So it's actually the picometer is one of the really, really small units that chemists like to